Okay, we're now recording to the cloud. Thank you for coming, everybody. It's my pleasure to be here. Pete, thank you so much for an invitation to visit the university and the chance over the last couple of days to meet so many students and see so many forests here in around the Flagstaff area. How many of you have had a chance to visit British Columbia? Oh, quite a few. Okay, well, let me give you a quick overview for those of you who have not or may not have remembered some of these details. So we're the westernmost province in Canada, and the province itself is about 75 million hectares, so it's a very large area. And as you can see, it's also geologically and geographically diverse. So this is giving us an idea about the mountain range distribution. And then, of course, we have these really strong environmental gradients between the ocean and the interior, from the south to the north of the province. That influences the climate, the vegetation, and ultimately the fire regimes as well. Of our 95 million hectares, 95% of it is publicly owned, and we refer to it as Crown land, or managed by the provincial government, with tenures out to forest companies or to other agencies that manage different resources. And of our total province, about 25% is currently managed for timber production at a sustained rate of about 1% harvested per year from that 24 million hectares. Now, given that geographic and geological variation in the province, we also have a tremendously diverse vegetation types. And so the colors on the map here are depicting 18 different biogeoclimatic zones. And if we look in the center in the map where the reds and yellows are, the kind of warm colors in the center, they're telling us about the elevation gradients from valley bottoms moving up from grasslands to submontane, montane, and then right up into subalpine and alpine vegetation. So that's our main valley bottoms in the interior, transferring up into the mountains, which are the purple and pink colors. As we move a little bit further north, the blues, the dark blue or teal blue in the center, and then the light blue up to the north are our subboreal and boreal forests. And of course, the green along the coast is the coastal temperate rainforests. And if I'm generalize a little bit, those three have very diverse and different fire regimes. On the coast, being a very wet climate with very complex old growth forests, fires are very, very infrequent. If we move to the north to the subboreal and boreal forest, crown fire regimes dominate with fire return intervals of about 100 years or more. They can be much longer in some of those mesic forests. And then as we come back down to that mountain gradient from valley bottoms up to the subalpine forests, it's a lot like the mountain ranges and the fire regime variation that you have in the western US, where we start with these surface fires that are very frequent in the lowest elevations, transitioning through mixed severity with low severity and surface fires at greater abundance at low elevation, and shifting more and more to a crown fire regime as we move up in higher elevation. Now, wildfires are common in British Columbia. On an average year, we have about 1,700 fires and about 150,000 hectares burn. We're at 60% lightning, 40% human ignitions on the average year. And the dots on the map here are showing the three major fire years prior to 2017. And it gives you the sum, the total area that was burned. So 1958 was winning, 860,000 hectares. And that's the pink color with quite a bit of the larger fires up in the north. 2003 is noteworthy. Not that there's such a huge amount of area that burned, but most of it was in the southern portion of the province. And in 2003, many communities were impacted in the wildland-urban interface. And it's the first time in BC that we had a major impact on a local community. And then along came 2017 and 2018. So in 2017, 1.2 million hectares burned. This province was in a state of emergency for 10 consecutive weeks from the beginning of July through till early September. In 2018, we thought we were out of the woods last summer. You know, we made it to the middle of July, and in the middle of July, only 75,000 hectares had burned. It had been moderately warm. And then we shifted about the first weekend in August, which is the BC day-long weekend. We went to blocking high temperature regime, or blocking high system, warm temperatures, we started breaking temperature records, and we didn't get precipitation again in a meaningful way until into September. And so in the month of August, into that first week of September, over a 6-week period, we burned 1.3 million hectares. And those are the polygons that are superimposed there in the orangey yellow color. We've spent over $1.2 billion Canadian, but that's still a lot of money, over the last 2 years, trying, in many cases unsuccessfully, to suppress these fires. So these fires were moving, they're exhibiting fire behavior that our fire behavior and our fire managers are telling us the fire behavior is exceeding anything that they have seen before. They were spreading rapidly. There were many occasions when it was unsafe to have firefighters, either aerial or ground support, trying to suppress these fires. So despite all our modern technology, we were unable to bring them under control. I want to zoom in for a moment on the 2017 fires and give you an idea of how big they are. The plateau complex was 19 fires that ultimately merged together. It was burning just west of the cities of Nazco and Quesnel, and it topped 520,000 hectares, so 500,000 hectares in that one fire alone. Just south of it, Hansville-Risky Creek, 240,000 hectares, and then down in the bottom right, Elephant Hill, 192,000 hectares. Now, if this was northern Canada in the boreal forest, these numbers wouldn't be so shockingly large. But Elephant Hill started in the grasslands, and it burned through our ponderosa pine and interior Douglas fir forests, and then up towards our more mesic forests. These were forests that we thought had a mixed severity fire regime, and it burned at high intensity, primarily at crown fire. And so we have these landscapes, all three of them, kind of moving up that gradient, that burned at much higher severity than anybody had anticipated they would, given their composition and their structure. So Douglas fir dominated in the mixed conifer, very complex structures, lots of fire scars embedded in them, embedded within a matrix of even-aged forests that used to be dominated by lodgepole pine. And I want you to hang on to that thought as I go. Now, like in the Western US, one of the leading questions is, are these fires being driven by climate change? So how much of this is climate? And I wanted to start here with our benchmark, what used to be our benchmark in 2003. So this was that fire year in modern times, recent times, where we had multiple WUI or interface fires that were impacting homes. And in fact, in that year, about 310 homes were lost. It was the first time we'd had an impact like that in British Columbia. The map is showing you the fire danger ratings based on the fire weather indices. And you can see that the southern portion of the province was in extreme fire danger, and much of the province was in moderate to high fire danger. So that was the beginning of August, when those fires became quite extreme in 2003. And here's beginning of August in 2017 and 2018. 2017 was particularly shocking. If you look at that map, the only place on the map is this little location near Prince Rupert, just below the Alaskan Panhandle, that managed to be in the low category. The rest of the province was in extreme or high, and it was sustained that way for several weeks between the end of July through to the end of August. And then we had repeat performance in 2018. In 2017, it was that central part of the province that burned with such large fires. 2018, the north central part of the province burned, but the other thing that was remarkable about that year is that fires were burning in all of the fire districts in the province. We had fires burning, crowning in coastal temperate old growth forests on the west side of Vancouver Island, which nobody thought they would see in their lifetimes. We had simultaneously multiple communities on evacuation in the central part of the province, and then fires of note. In fact, there were 50 fires of note. Those are fires that are visible from communities and have communities under threat, either evacuation order or alert. So 50 simultaneously spread over 95 million hectares. It was overwhelming, the resources. So clearly, I would say that these extreme weather events, the extreme droughts that we've been experiencing, are contributing to these fires. Recent research on the 2017 fire weather conditions tell us that the fires were probably 1.4 times larger than they would have been in absence of anthropogenic climate change. Now, I don't want to blame everything on climate, because of course when fires burn, when we think about a fire behavior triangle, fire people talk about triangles all the time. So weather is one component, topography is the other, and then the third, of course, are the fuels or the vegetation that we're burning. And we have some vegetation issues in British Columbia that kind of mirror many of the issues around vegetation and forest management and forest condition that we've heard so much about in the Western United States as well. So like many Western countries, we have a view of fire in our society. Let's see if it'll go. There we go. We have a view of fire in our society that it is dangerous, that it's damaging and destructive. And here is a lightning ignited fire burning through the night, crowning at high intensity, across from the downtown center of the town of Nelson, British Columbia. And so this was in July of 2017. And as you can imagine, people in this community were highly concerned about that fire and immediately wanted it to be suppressed. And so our policies in British Columbia, as in other jurisdictions, has been to detect and suppress fires in order to protect lives and homes. And we've done that really, really effectively. And in BC, because so much of our forests are actually used as the basis for the economy, that got translated into protecting our livelihoods and meaning our forests then from fire as well. And so our policies for fire suppression have been applied kind of as a blanket policy across the province. And in fact, we've become so good with professional wildland firefighters meeting their objectives that we have successfully suppressed 92% of fires before they exceeded 4 hectares in size and within 24 hours of ignition since the 1970s. And so what we're discovering is that there are some consequences, unintended consequences of that action. Now, I'm going to start with a small caveat that, of course, you can imagine the role of fire suppression has varied in different forest types around the province. So in the dry forest, which I'll talk about first, we have altered those fire regimes by suppressing fires, and we've been asymmetrical in which fires we're best able to suppress. It's the lower severity fires, the ones that are burning as surface fires, that are burning through understories and scarring and damaging, but not killing the trees. And so then it's the fire scar record, the fire scars embedded within those trees that give us records of past fires and occurrence of those surface fires and allow us to compare our past forests to our modern day forests. And so first I'll talk about the dry forests and then move to some of the more mesic forest types that have a crown fire disturbance regime in contrast. So how many of you have been in the tree ring lab here and had a chance to look at all those rings and measure and count? Well, like the work that happens in the restoration ecology and in Pete's labs, we also use tree rings to date these different events. And so in this example, a Douglas fir from the interior of British Columbia from our research forest. The pith date on this tree is 1809. And in 1837 was the first fire that damaged about 40% of the circumference. And no longer, that portion of the circumference was no longer forming annual rings. It was damaged again in 1858. And at that point, it's just that upper arc of cambial tissue that continued to grow. And for the subsequent 140 years, this tree continued to form rings, healing lobes, or forming a healing lobe to protect those damaged tissues and to protect it from subsequent fires. So we have been looking for evidence of these fire-scarred trees and collecting them across our study areas. And we've worked on about 200 study areas now across the interior of BC, including the Alex Fraser Research Forest. And these are kind of results right hot off the press, because I left Vancouver last Monday at 3 in the afternoon, and Wes defended his thesis at noon. So these are his star slides from his presentation from his master's thesis defense. So he's working at the Alex Fraser Research Forest, which is in the heart of that region that burned in 2017. It did not burn, I think just by dumb luck. The wind blew the fire away from our research forest. Our dry forest belt for our research forest did not burn. In fact, our more music forest did burn. We lost a third of the Gavin Lake site to wildfire in 2017. So back to Wes's work. What I'm going to show you, and I'll show you a couple different versions of this in a couple of case studies, are these fire charts. So in the chart, each horizontal line represents a research plot. The length of the line tells you about the lifespan of the oldest tree within that research plot. The black triangles that point down are the fire scars. And then you'll see in amongst the fire scars some white or gray triangles, and those are indicating when cohorts established either independently or in association with a fire scar and a fire date. So here are the sequence of plots that Wes analyzed. And this is a fairly high density network. He has 27 plots in an area that's just over 110 hectares. And we sampled at that high density so that we could understand not only the temporal changes, but the spatial variation in the fires as well. So as you can see, even in central British Columbia, there is an abundance of surface fire in our historical fire regimes. So he documented 23 fires and a return interval on average of about 15 years with some variation. And these are plot level, or that's at the plot level, that the intervals from fire to fire range from 7 to 32 years within an individual plot. The things you might notice about the chart. The last fire that burned was in 1943, but there had been few fires in the early part of the 20th century, especially when we compare to the period in the late 1800s. The most widespread fire, and the one that seemed to have the biggest impact on the contemporary forest, burned in 1863. So it burned the maximum number of plots, so it was our most widespread fire recorded in his study area. And you can see all the gray triangles to the right of that red line. Those are cohorts of trees that established in the 15 years following that fire. Now, he did demography work as well, looking at the age of the trees in these forests. And this is what his age histogram looks like. Prior to 1863, the forest or the trees in our static age distribution represent an uneven age forest with very few number of trees entering into the population fairly continuously through time. So a few trees establishing and surviving through to the present to be sampled in each decade. And then you can see after 1863, there's a large number of trees that come in those post-fire cohorts. And in fact, they counted for 84% of the trees that he had cored. They came in post-1863. Now, it looks like that was a pretty high severity fire. And so what he did next was map out the different types of evidence for the 6 most widespread fires. So they're in chronological order from left to right across the top and then the bottom. And as you can see, 1863 stands out. It's the most colorful one. And it's most colorful because the yellow areas are showing sites where the fire burned through the area and left a fire scar only. The orange are areas where there was fire-scarred trees and trees and a cohort that established simultaneously. And then the red plots are the ones where there was no fire scar formed at that point in the landscape, but a cohort did form. Now, in amongst that cohort, there might still be veteran trees that survived but did not produce a scar. Nevertheless, we've called these our highest severity or high severity points or plots in the 1863 fire. Now, moving back through time, it doesn't look like very many cohorts established in those previous fires. And I want to kind of give a little caveat here. If you think in 1817, if the fire had been intense enough that some cohorts did establish, those subsequent fires in 1831, 40, and 63 might have killed and removed those trees so that that evidence is no longer visible to us in the landscape. So we cannot eliminate the possibility that there were cohorts formed in those previous fires, but we simply no longer detect them. However, I can say with confidence that 1905 must have been a low severity fire because it left only fire scars and only at some of the plots. And that's our most recent fire. It left no cohorts, or resulted in no cohorts being established. And all of those trees that established in 1863, in many cases, the fire was burning within the same plots as some of those smaller, younger trees. So the fire could not have been that intense or that hot in 1905. So if I come back to that 1863 fire, one other line of evidence suggests to me that it couldn't have been a really high intensity stand replacing fire. And I've been taken out over the last couple of days and seen some sites here in Arizona where the trees are scorched black and nothing survived. That's pretty high severity. If I'd gone into this forest in 1863, clearly there would have been patches that had burned at high severity and lots of trees establishing. But I also know there's a lot of legacy trees. There's a lot of trees in that 100 hectares in amongst those burned patches that survived the fire and recorded a scar and persist on the landscape today. So that 1863 fire, I would venture to say, was actually more of a moderate to high severity fire. It was not a stand replacing fire. It did not remove the evidence of the other fires that had preceded it on the landscape. And I think the last compelling piece is look at what happened after 1863. The red bars are showing you time since last fire on each and every one of these plots. There has been so few fires, surface fire burning through this area, that small trees that are now 100 to 140 years old are still persisting on that landscape. Had we continued to have surface fires at a return interval of 15 years, I think many of them would not have survived. And so the structure of that forest and the density of the forest and the fire hazards that exist there today, we have concluded is a result of the change in the fire regime and these long time since fire intervals relative to the maximum intervals we recorded at the plot level in those same plots. Now there's some standard culprits. We can call it fire suppression. Certainly in modern era has been really important to explain why there are no fire scars and no fires recorded in this part of the landscape. But we also had land use change. So after the 1860s, the gold rush arrived in this area. In 1859-60, land use change occurred very rapidly with settlers coming in and introducing grazing mammals. The other thing that happened in this landscape was after the gold rush, as Europeans were arriving, the indigenous people who occupied this space, the Shuswap people, North Shuswap people, were essentially extirpated from their traditional territories. And so we also think that the removal of the ignition source of people from the traditional territories, including our study area and research forest, was an important factor. And let me show you a second case study to support that assertion. So now I'm going to take you further south. I'm going to take you to our wine belt. This is down in the Okanagan of British Columbia, and we're at West Vaseux Lake. And so this is work that was completed by Alex Pogue. We're looking here at a panorama shot of her study area on the west side of Vaseux Lake. And you can see in the foreground this kind of hilly slope that's today forested. And then the rocky ridges in behind represent or form the eastern edge of her study area. Up at the north end to the right, the rock ridges come almost right down to the water. And at the south end, there's an ancient archaeological site, a well-documented ark site where the Syilx First Nation lived for millennia. Now we chose this site to work on for multiple reasons. But one of the reasons was this was a location where we thought if fires are going to burn in this part of the landscape, the majority of the ignitions that we would see in the 400 hectare area would have to be ignitions from within that 400 hectares rather than spreading in, because they'd be pinched off. They couldn't cross the, well, they could maybe have firebrands across the lake, but spreading across the lake was unlikely. Spreading in from the north or from the east would be limited because of those rocky cliffs. And then to the south, it kind of ends down in this flat area and then down onto the lakefront itself. So let's take this view and then take a look at a bird's eye view down onto the study area on the left. So there's the lake, the rock bands on the east, the little green boxes were too steep for us to safely sample. And what Alex did was put on the checkerboard grid and then sample every second square across this 400-hectare study area. And this is an idea of what it looks like from inside the stand. So there's ponderosa pines, there's Douglas firs. The Douglas firs are abundant in the understory with big ponderosa pines and Douglas firs forming the overstory as well. And here's Alex's fire chart. So each one of the red ticks is a fire event. Each one of the plots is distributed somewhere in the landscape. And you can see that there's a fairly significant shift that takes place after about 1865. So prior to 1865, she detected 27 different fires with fire return intervals of 7 years, and about almost 20% of the fires being early season or spring ignitions that created scars in the early wood of the tree rings. If you look at the patterns, there's frequency. The frequency or the intervals are short. The patterns, the way that the fire scars are aligning amongst the plots is quite asymmetrical. And when we mapped it out, in fact, they're in patches in different places in the landscape, and only one of them burned right close to the lake itself. So most of them were upslope and in different locations up that slope. She did some fire climate analysis as well and discovered that on average, those fires were occurring in years that were average or slightly moister and cooler than average. Now let's switch to the post-1865 era, where there's fewer fires and longer intervals, and only a couple of the fire scars during that era were formed in the early wood. You can see that the fires are longer intervals between them. They're much more widespread on the site and more synchronous. And in fact, when we mapped them, a lot of them came almost down to the lake edge. When we looked at the fire climate associations, they burned during the hottest and driest years during the 20th century. That last fire is 1973, and it was recorded in the BC Forest Service fire records. Now, in this area, it's hot and dry enough each summer that climate should not be a limiting factor. And the vegetation is kind of grass and shrub with trees. So we don't think, in fact, fuels would be particularly limiting. And so in this 400-hectare patch of forest, we've come to the conclusion that this is an ignition-limited system and that the ignition source has been primarily humans over time. So that record prior to 1865, it turns out if you look at the spatial patterns, the seasonality, the size of the fires that we were able to reconstruct, they strongly align with the oral history that was shared with Annie Kruger, who is the fire keeper. In this particular, with the Sylph people, fire knowledge is passed as a matriarchal line, and her oral history was recorded in the 1990s before her death. And she described patchy fires that burned in different seasons to generate 5 different food crops, the big 5 that were berries and below ground root plants that were their primary food sources. When we did a prescribed burn in 2013, guess what came up in the understory? The big 5 food plants. In 1862, smallpox swept through the interior of British Columbia, and mortality rates were very high, and the documentary record shows that that archaeological site was abandoned. The site remained empty, and unlike most fire records, there's no fire scars that occurred during the European settlement era. Now, to the best of our knowledge, there's never been cattle grazing on this particular site, but we do know that starting in the early 1900s, they started putting in railway lines. And they were surveying in the 1910s, and then the railway line, the Kettle Valley Railway, was installed and ran between 1917, that first widespread fire in the 20th century, to 1976. And it was decommissioned in 1976, and it is now a property managed by the Canadian Wildlife Service as a restoration property for grasslands and endangered habitat for reptiles and raptors. And so that's why we're working in a prescribed burn program there. So it's this really amazing fire history that pretty much exclusively is driven by a human story. Now, like Wes's sites, the forest demography, the shape of that forest, the species composition, and the density largely reflects the changes in the fire regime through time. So you can see a big pulse of trees that established and then persist in this landscape after fires were disrupted. The fire regime was disrupted in 1865. You can see that I would interpret those fires in the 1900s. Many of them actually started right down by the lake, by the way, and spread up slope and scarred trees throughout the study area. But I would also interpret that they must have been fairly low intensity because these young trees that had recently established and continued establishment, they weren't removing those trees from the sites. And so we've had this fairly continuous ingress, and we see in much of this landscape today very dense dog hair thickets of Douglas fir that established at some point during the 20th century, with these scattered kind of big wolf trees being the old structure distributed widely across the landscape, and then this medium cohort that established in the late 1860s. And so this is a site that we think in the past, those frequent low impact but patchy fires had a landscape of grassland with scattered trees. And what we see today, following infrequent but widespread fires, and then subsequent fire suppression, these much denser forests. And so choices are being made to actively manage this forest land by removing trees and implementing prescribed burns. So if we scale up past the stand level in these patches of forest and start to look at our landscapes, patterns are repeating themselves in the interior British Columbia at the northern end of these grassland and ponderosa pine and Douglas fir woodland ecosystems. In absence of surface fires, we're getting changes in the vegetation structure. So here the light gray are the grasses, the dark gray are the woodlands and trees. We see over just a 50-year period, more trees dominating the ecosystem and infilling both of grasslands and increased density in existing woodlands and stands, leading to fuels buildups. And we've concluded reduced resilience. Now, we've been giving this presentation in parts of British Columbia for a few years, sharing these slides and this story, and there's been some skepticism about whether or not there were significant changes taking place on our landscape. And then came 2017 and 2018, and there's some more open minds, I think, now, especially given that these are the ecosystems that are burning at high severity. And so there we are with our fuels build up and these extreme weather events that we believe that has been shown to connect to anthropogenic climate change. And we are getting large, fast-moving, intense fires exhibiting behavior that has not been observed by our fire managers previously. And so there's the fire severity map for the Elephant Hill fire that started in the grasslands and burned mostly through ponderosa pine and interior Douglas fir woodlands. That's 192,000 hectares of forest that's burned. So the fire suppression paradox, a kind of a model that was developed here in Arizona, is applicable as far north as 53 degrees north in the Alex Fraser Research Forest, in Williams Lake, and in the Kootenays, and in the Okanagan of British Columbia. Now let me switch here to move from our drier forest types where the surface fire regime has been disrupted back up to our subboreal and boreal forests where it's a crown fire regime. And there's often an argument that says, well, in the crown fires, fire return intervals were 100 years to 200 years. Fire suppression has really been in effect for much less than that, so how could we have disrupted the fire regime? Well, it turns out when you're 92% successful at putting out fires before they're able to spread and have impacts on the landscape, the net effect is that you homogenize those forests. And homogenization of the forest through fire suppression is one of the key factors, along with climate change, that was used to explain the mountain pine beetle epidemic that affected 18.3 million hectares of forest in British Columbia. Mountain pine beetle has spilled over the Rockies and has expanded through into Alberta, expanding its range into naive host trees and into jack pine, which is related to lodgepole pine, but again, a naive host. So there's dead trees in our forest intermixed with living trees in our mixed conifer stands. So the fuel structure is changing, and the fuel loads are beginning to change as well as those dead trees begin to fall and jackstraw onto the ground. We also responded through the forest industry, took action, and they went in and salvage logged, in particular areas that were accessible, that were close to mills and adjacent to communities. And so the salvage logging that was done also left behind large number of residuals. And so what we're finding today is that these landscapes are burning through mountain pine beetle affected fuels that were not salvaged, or through regenerating forests in which the salvage, the woody debris that was left behind is at such loads that they're not fuel breaks in the landscape, they're actually conduits for fire. And so as a result, we are seeing the fire behaviors and the impacts on human communities because of those changes in the fuels and their distributions. Oops, there we go. Now, in part, this is a story too about how we manage for fire. This chart is showing you the red zones in the bottom show you that we used to implement broadcast burns across the landscape for both silviculture and restoration. Between the 70s and 90s, we would burn tens of thousands, and some years up to hundreds of thousands of hectares per year in combination with silviculture and restoration. That stopped in the mid-1990s. And that's also the time, a decade later, when we started all those salvage operations. And so we significantly changed the ways that residual fuels are being left after our human activities, whether they be salvage logging or whether they be timber production in green forests. And these, we believe, and we're working on testing hypotheses about how they have contributed to the intensity and the severity of the fires that have burned. So after these fires, we've kind of said to our provincial government agencies and to our provincial political leaders that this cannot be another wake-up call. 2003 was supposed to be our wake-up call, and not much has changed since then. So these fires, I think, have resonated with people and sent the message that we are not resilient to wildfires and climate change, and that transformation, not just tinkering with the system, but true transformative change is needed. So let me spend the last few minutes, about 5 to 10 minutes here, telling you about some of the frameworks and some of the changes that we're advocating and that are being implemented as I speak. So I want to point out, first of all, that what we do to adapt to climate change and implement these transformative changes cannot be the same thing everywhere. And I'm going to demonstrate with the dry forests and then our more mesic forests with these different fire regimes. And I'm going to point out as well, what we do in our coastal forests is going to have to be something different again. But as a general framework, my rule of thumb is if you want to fix a problem, remember or figure out what your problem is and then make sure you're fixing the right thing. So if we come back and think about these systems, we have fuels build up in the surface fire regime because of fire exclusion and suppression. And we have fuel build up in the crown fires because of homogenization, forest health issues, and then subsequent management choices. When we superimpose on that climate change and the extreme fire weather, we have a problem. We're seeing large and fast and intense fires, and we're seeing those across both fire regime and forest types. So I'm going to fast track to the bottom of the slide and say, I think we have to increase resilience of communities, and we have to do that with our forests and vegetation as well. But I think we need to focus on our human communities, because people worry about their homes and their communities burning down, but they might not be as concerned about the forests as we are. So a big part of the messaging and the I guess, the role that I see us playing as educators, one of our strategies is to work from the communities out as we plan both our ecological and our social ecological work. And so, of course, the missing piece in the middle is this adaptation, and that's the transformation of our wildfire and forest management. So a few examples of how we've done that. We've made some progress within our wildfire management. Until 2012, the policy in British Columbia was to detect and suppress all fires. As of 2012, there was a new mandate that said we are going to use fire to encourage sustainable, healthy, and resilient ecosystems. We would use managed wildfire on the landscape when it was safe to do so. So the entire province has been triaged. We've identified, of course, WUI and critical infrastructure where suppression will be enacted right away. More remote areas where there's no critical infrastructure, lives and homes at risk. Those areas are in the managed wildfire zone. And then, of course, there's an intermediate zone that has some choices that need to be made based on the conditions at the time of the fire. And you'll notice our modified response or our managed wildfire, we have fires that are tens of thousands of hectares that we are letting burn, creating the natural diversity, letting fire be back on that landscape, breaking up the homogeneous landscapes that currently exist. I've hinted at this already. We're using both mechanical thinning and other forms of mechanical treatments and prescribed fire to do restoration and to improve forest resilience. Prescribed fires, you might imagine, we have some resistance to the concept. And so it's been really important, and we've advocated hard for monitoring for the efficacy and then thinking about those surprises that we've not yet anticipated. And it might seem kind of ridiculous to put this on here, but to date, the provincial government nor the federal government has been willing to fund any efficacy testing of the fuels treatments and the restoration treatments that are ongoing. It's private foundations and conservation organizations that are funding us to do so. So there, by the way, the photo, Arnett et al. And the fire map, that's Vaseux Lake. That's a prescribed burn over about 150 hectares that we instrumented, and then we're able to calculate the severity of the burn. Now, we've had some negative feedback on that particular prescribed burn. And I'd like you to notice how there's lots of gray and yellow, which is the low intensity, and only small patches of higher intensity. And so our counter when we get that resistance is, how do you want your smoke? Okanagan Lake is across the lake from Vaseux Lake. It's about 100 kilometers north. And in 2003, it burned at high severity, high intensity, and it produced smoke in the middle of August that, of course, we could not control. I don't have to tell you that that can be a problem. I know you've experienced it as well. So the public is concerned about prescribed burning, physicians because of the smoke and health effects. And then the third, which is becoming a real barrier for us, is actually the BC Carbon Initiative. They're concerned about the amount of smoke that we're putting into the atmosphere, and they want proof that, in fact, we reduce the chance of a crown fire like this sufficiently that the trade-off of the small amount of smoke under controlled conditions is justified. And so that's ongoing work in the province. After 2003, we not only triaged to figure out where we could burn fires and let them be managed wildfires on the landscape, but the province did a strategic threat analysis. And so the map here is telling you about the places in the landscape where the fuels, the ignitions, and the people all meet. And so the red areas are where we had the highest fuel hazards, and the yellows and golds are also high and moderate, and the greens are going to be lower and less of concern. The dark blotches are all the wildland-urban interface around our urban areas. So we identified these areas that needed to be treated. There's 1.6 million hectares of them. And there was a funding program put in place with $78 million for fuels mitigation, which sounded at the time incredibly large. But it had to be spread over 350 plus communities. So there we are by 2017. We haven't moved very quickly. These communities had to match the funds from the provincial government. And by 2017, half of the communities had developed a community wildfire protection plan. So they had assessed their fuels and developed prescriptions, but only 26% of those with a plan were actually implementing the plan. So that's only 12% of the communities. And with our $78 million, we treated 12,000 hectares. The system doesn't seem to be working. And this has become a huge problem that we have not yet overcome this barrier. It's the communities smaller than 5,000 citizens who live embedded in these fire-prone environments, who need to have fuels mitigation, but at 5,000 citizens, they don't have the tax base, they don't have the people to take care of the administrative costs, and they don't have the expertise. If you go down to communities that are fewer than 1,000 people, those are the most vulnerable communities, and many of them are our First Nations communities embedded in this forest matrix, and they have no access to these resources whatsoever. And so this has become a serious concern, and one that we're working with communities to try to come up with solutions through the community forest network in the province. Given that we have 95 million hectares and 24 million hectares of those are being managed for timber, it's important to think about what the role of that forest management and our existing paradigms, how it's contributing to the problem. This, unfortunately, is a typical satellite image view of what British Columbia looks like. It doesn't matter if you're on the coast, the southern interior, the mountain systems, central interior, or the true boreal. This is what we do to our landscapes. So we have these patches of forest that are being largely clear-cut. There's low retention in some of those stands. The patches are distributed across the landscape in this kind of checkerboard because once the companies have harvested timber in one patch, they have to regenerate it to stocking standards and to have the seedlings growing tall enough that they're free to grow before there is a release of adjacent patches of forest for harvesting. So what that's done is driven us to encourage planting or regeneration of conifer trees that will survive and grow quickly. So we have millions of hectares of forest that are regenerating monocultures of lodgepole pine, which is the next generation of mountain pine beetle epidemic. So this is a serious problem. We've identified, of course, it comes from managing for single values for timber primarily, and our land management or our timber management is on a volume-based instead of an area-based. So the companies are not responsible for the long-term management of their management areas, the government is. They're allowed to access the timber, and then as long as they fulfill that regeneration expectation, they can move on to the next patch of forest. And so our tenure system is a problem. We're managing for stable states, trajectories, trying to resist disturbance and get to those harvestable timber at an 80 to 100-year rotation. We're not looking at the role of natural disturbances. There's a lot of resistance to change and inertia within our management systems. And I would say that until 2017, we had our blinders on as to what were the cumulative effects of human impacts, and fairly naive about how we were going to respond to climate change. The forest companies haven't been very good collaborators from a research perspective. They're willing to share some maps, but not willing to fund graduate students. They're happy to have us present at conferences and workshops, but really that's the limitation of the collaborations that they've been willing to engage in. And in part because they don't manage for fire and it's a net cost anyway, so why invest in the research, which is just another cost. After burning 2.5 million hectares of the timber harvesting land base, there's been a bit of a watershed change in their perspective from our forest managers, and senior managers are now coming to me and saying, we think there's a problem with this model and we want to change. And so there's the beginnings of shifts towards long-term and landscape level management. Good, shows up here. So let me end with a mural that has two parts. This is my fire dumb landscape, and it kind of summarizes the multiple problems that we've had in our landscapes. So at the big landscape level, across our forested lands, we have been managing for timber with this stand level focus. And by not looking at processes and thinking about landscape level processes, we've ended up with this homogenized landscape that's highly vulnerable. When we begin to intervene and try to make changes to forest management or implement wildland urban interface treatments or advocate for prescribed burning, there's resistance. And there's policy conflicts, there's reasons, all sorts of rules and regulations that won't allow us to do some of what we need to do. For example, in the wildland urban interface, until 18 months ago, once you thinned out the forest, you had to replant to stocking standards, which seems to defeat the purpose. Like other jurisdictions, we don't have a market for that small diameter wood that we need to remove from these forests. And then I want to come back down to our citizens. Many people are oblivious to the fact that they live in a fire-prone environment, and it's not if, but when. The fire from last year was not a once-in-a-lifetime event. And I would say as long as people are not telling their politicians that they want change and attention, it's not going to come. And so we remain with these vulnerable communities. So the steps we need to take to go from a fire-dumb to a fire-wise landscape on the right, to coexist with fire. I'm going to start at the bottom up because, again, remember I said I think we have to start with communities. And if we can educate and engage citizens so that they're better aware of the situation, their fire-prone environments, understand the vulnerability of their homes and communities, they'll be more open to taking personal responsibility, but also open to supporting their communities when wildland urban interface treatments are underway. We need to be proactive with our landscape planning, and we've been talking about WUI treatments and then going out 10 and 15 and 20 kilometers to create landscape level fuel breaks in strategic places that would allow us to, in the case of fire coming towards a community, change the fire behavior and increase the chance of us stopping it before it burned into that community. And again, coming up with some way that we can take the materials released or generated through mitigation into some stream other than pile burning and putting the carbon back into the atmosphere. Now these two, again, are really important because the next stage is going to be adding fire back onto the landscape. And until that woman sitting in that chair thinks that she is safe from fire, either in her home or in her community, she's not going to be very happy when I start telling her we're going to do prescribed burns and have managed wildfire in her backyard and beyond. So we can manage for resilience as a target as opposed to the economic driver of timber production. There's a strong movement in British Columbia as in other places to involve Indigenous people and to incorporate their Indigenous knowledge with our Western science to inform evidence-based and evidence-based management, and then to have a framework where we're testing for efficacy and have that monitoring in place so that we can be truly adaptive. And then we still have to deal with wildfires on the landscape that are going to put communities under threat and resources in critical infrastructure. So we need to increase our capacity to do that effectively, but also diversify so that our wildland firefighters are not just suppression experts, but that they have the skills and capability to also be doing fuels mitigation and prescribed burns, and to be doing so with confidence. Thank you. I welcome any questions.
I enjoyed your presentation.
Thank you.
So I was struck by the apparent vulnerability and northern populations of Ponderosa Pine. It seems counter to a current paradigm in climate change ecology that it's the trailing edge of the southern populations that are most vulnerable to warming and climate change. Yet your example is a leading edge, northern population, highly vulnerable. So I'm wondering if this climate change paradigm needs to be revived.
Yeah, I think if we think about just the ecology of Ponderosa pine, I would think it's that southern edge where it's going to be the heat tolerance, is, the physiological thresholds for its heat tolerance and drought tolerance would be likely to be crossed. We've had some very dramatic and pronounced droughts also at the northern end of its distribution, although it's really, I think, that interaction with fire in these extreme events that's the driver. And so maybe that difference between it being a direct effect interacting with the physiology versus an indirect effect where it's the climate-mediated disturbance interacting with the trees that can also be stressed in the environments where they're growing, that may be playing a role. But I agree, I think we have some really great frameworks for testing and to think about climate change. But I think we've all been talking about, you know, expect the unexpected. What are the surprises? Maybe you've just hit on one of those surprises that we need to, yeah, there you go. Let's go lateral instead of, you know, and dig a little deeper into those thoughts. Yeah. Yeah.
Guessing if it's substantially different government policy about how to access timber.
Yeah, if you want to raise everybody's blood pressure in the room in British Columbia, bring up the words tenure reform, and then you've made 100 best friends. So fundamentally, we probably have a tenure reform problem. It's something that we really need to seriously think about. I think there's some low-hanging fruit, though. So we know now that the abundance of logging residuals, particularly after salvage logging, is a particularly strong problem. We know, I mean, there are still over 1 million hectares of forests that were salvage logged in the last 15 years where all those residuals were left, and they're still out there in the landscape trying to grow some trees underneath them. So that's a problem. We're now salvage logging as fast as we can all those trees that burned in 2017 and 2018. So are we repeating the same mistakes, or are we doing it differently? So maybe we need to think strategically about how we salvage and how much residual is allowed to leave. Or if we're leaving those residuals, maybe we have to go back to those programs of prescribed broadcast burns and take a little bit of smoke under controlled conditions before we replant those forests as the trade-off. And I've been told hundreds of thousands of hectares in northern BC where we've burned forests that are less than 20 years old. And they burned to a crisp because they were still in knee-deep slash. You know, the coarse wood was still on the ground and very contiguous. So there's an easy one. Like, we need to rethink those slash policies and those residual policies and get prescribed burn back into our silvicultural systems. In our dry forest belt in BC, we spent the last 15 to 20 years chasing dead mountain pine beetle fuels. So we've been harvesting dead lodgepole pines, and we're very, very good at it. But that's a really different prescription than writing harvesting plans for interior Douglas fir uneven aged stands. And so we really need to rethink how we're managing those forests, and that is underway. But we did have a few years there where people were writing prescriptions and going in and clear cutting, interior Douglas fir and ponderosa pine stands that were uneven aged and treating them in the same way that they were treating, salvaged pine. So there's a couple of fairly easy ones. The third is being initiated by the forest companies, and what they've asked for is landscape level planning. They want to stop focusing on those stands but start thinking at that bigger scale. And one of the things that they're looking at is, one, understanding historical fire regimes and departures from them, and then strategically looking at their landscapes as they are today and making choices about where would be landscape level fuel breaks that we can cultivate and maintain as we regenerate forests, so that we know that those are out there and we can use them as anchor points for subsequent fires or as fuel breaks to change fire behavior. In BC, you're not allowed to plant or write into a prescription aspen. Aspen is competing with our conifers, and so aspen and birch are removed with glyphosate or by brushing. And there's not one district manager in the province of BC that will accept a silvicultural prescription that includes aspen. I think that could change yesterday, and we would be better off for it. So there's a few examples. Okay.
I think we're out of time for this portion of this discussion, but we'll have a grad student discussion in room 34A, and then please join us for dinner at the Macmillan at 6:30. Thank you so much, Lori.
You're
for
welcome.
presenting.